Yeah, we'll be looking at the quotient rule at one. Quotient rule, when is it used for? When can we use quotient rule? Quotient rule is applicable when you have a fraction. I mean, you have numerator and you have denominator. Okay, so in that case now you want to differentiate. That is when quotient rule is applicable. Okay, and what is the form of quotient rule? Let's see the form. The form is this: you're having u over v. This is your numerator. You use your numerator, and your v is your denominator. And each of them are functions of x. You use the functions of x. V also is a function of x. Okay, so the differential coefficient now for a fraction will be equal to the denominator, you square that, b squared. Okay, then the v, you keep it constant, and you differentiate your what? The numerator, the u dx. Okay, then minus the one you have differentiated here, your u, you keep it constant, and you differentiate the one that you are keeping constant here, the v dx. Okay, but don't worry, we're going to do have example so that to explain this in detail. So this is that on quotient. Okay, let's see those two questions. Find the u d theta if u is this, and two if u also is also this. So these are the two questions we have. And you can see this is a numerator, this is a fraction, this is denominator. Okay, so let's see the first one. The first one, we have u equal to theta cos. And I want to tell you, it's not every time the function will be, it will be functions of x. In this case now, u is a function of theta. So it's not every time to be functions of x. It will be functions of anything. Okay, so in that case now, you differentiate respect to that function. You differentiate respect to that function. Use the functions of theta. Okay, so then the next thing to do now is for us to indicate what is my v. Let me start with u. What is my u? My u is this, cos theta. Can we get the u d theta? The u d theta will be equal to what? That's a product rule. That's a product. Okay, no. That's a product rule. That's a product rule. Theta cos theta. So you keep one constant, you differentiate this one, and that will give you minus sine theta. And then plus the one you are differentiating here, you keep it constant. You differentiate this one with respect to theta, and that's what? That's one. So I'm now having now, if I like now, I can write the positive first before the negative. I can write the positive first, and that will be cos theta minus theta sine theta. Okay. So that's my du d theta. Can we get the v is the denominator? So the v d theta is 1. The v theta is 1. Okay. So the next thing to do now is to apply the formula. Apply the formula. So the u d theta will be equal to, what's our v? Our v is what? Theta plus 3. That's our v. Our du d theta is what? Cos theta minus theta sine theta. Okay. I think my writing is big there. Then what do we have now? Minus u. Sorry, I have to reduce my writing. I don't know how to reduce my writing. I have to cancel this. So I want to be on a single line. So the du d theta is equal to, my v is theta plus 3, theta plus 3. Then to brackets, cos theta minus theta sine theta. Okay. So I've done v times du d theta, then minus my u is theta cos theta, then my the v d theta The v d theta is 1. So I don't need to just indicate that it's 1 all over v squared. My v is what? Theta plus 1. Okay? So that's what we've got. That's what we've gotten. So let's expand. That will be equal to theta times this. That's theta cos theta. Then minus theta times this, minus theta squared sin theta. Let's go to the 3, plus 3 cos theta. Then this one times this one, minus 3, minus 3, minus 3 theta sin theta. Then minus I want to make it this on a straight line. Minus theta cos theta all over theta plus 3 all squared. So let's see what I cancel out. This one cancelled, it cancelled. So we have that remaining expression. So what we can do, those ones that have 3, we can bring them together. We can bring them together. So okay, that will be equal to, let's write the positive for that 3 cos theta minus 3 theta sin theta. This 2, then minus what? Theta squared sin theta all over. And I want to tell you, in quotient rule, we don't tamper with this v squared. Don't expand it. Just leave it that way. In most cases, just leave that, except there is except the need around that. So we are going to leave that one there. So what can we do again? What can we do? Something is common, and we can do justice to that. We can do one more step for that. The u d theta. Let's just do the arrangement. Equal to 3 cos theta. Check it. There is theta cos theta here is here. Theta cos theta is also here too. So we can do that. We can factorize that. We can factorize that by taking minus out, then minus out theta sin theta. Take it out. So if you take it out, it remains 3 here. So depend on which one you are bringing first. I think since minus is coming outside, so it remain 1 here. So that will be theta. Okay, and here minus here times the minus here. That's what? That's plus 3. Okay, over what? Over the b squared. Theta plus 3 squared. So that's that on this question. And your theta sin theta can be in the front. It doesn't matter where it is, can be in the front. Okay, so since the minus is outside, we have to do this one first. Okay, so let's do the second one. The thing is very simple. Use the formula, follow the condition that require the question. It is a quotient rule, use it. The product rule, use it. And the another thing is just the algebra, factorizing, expanding, all those stuff. Okay, find the u d theta. The second one, u is equal to theta cos this over 1 plus theta over sin theta. Okay, so that's what we have. So what we do here, let's just break it down. What is okay is okay. The u is here. Okay, numerator is at u. Okay, it's okay. Just to avoid that confusion. Okay. Okay. I didn't even want to have it. So numerator is u. So what can we do now? Okay, can we change the numerator? Call your numerator. Maybe you call it w. Call this one your b. So because of these u here. Okay, but it doesn't matter. It doesn't matter. Just let for you to note what you are doing. It doesn't matter. So the u d theta, I'm going to do it straight away. U d theta will be equal to b squared theta plus 1 sin theta all squared. Then my v, the denominator, theta plus 1 sine theta times the derivative of the numerator. I'm going to use a prime for that, theta cos theta prime. I mean, the differentiation of this. That's why I'm putting prime on it. Then minus numerator, theta cos theta times the derivative of what? Derivative of the denominator, theta plus 1 sine theta. Let's put prime on that. That derivative. This like is acceptable. Yeah. It's internationally acceptable by putting that prime. You know the meaning of that. So the next thing to do now, can we do somewhere here? Theta plus 1. Let's get the theta, theta cos theta prime, which should be equal to, keep one constant, differentiate this. That's minus sine theta, plus cos theta, differentiate your theta with respect to theta. That's 1. So that's 1. So that's equal to what? Cos theta minus theta sine theta. So we've gotten that. So can we also differentiate the theta plus 1 sine theta? So that will be, that one is a product rule. That's product rule. So take one constant, differentiate this one. That's cos theta. Okay. Then plus the one you differentiated, keep that constant and differentiate your theta plus 1. Theta plus 1 respect to theta is 1. So I don't need to bother myself with times 1. Okay. So that's what we have here. So what we are going to do now is just make our substitutions. So I need a bigger space. So let's make substitutions. The theta will be equal to theta plus 1 times cos theta minus theta sine theta. Okay. Then minus the one there, theta cos theta times the derivative of that which we have there, which is equal to theta plus 1 cos theta plus sine theta all over theta plus 1 square sine square theta. Okay. If you square this, there are two items there. So to the square of this. Okay. So that's that on that. Yeah, let's keep something there. It's theta plus 1 sine theta. Okay, let me correct that. It's equal to, don't forget this, theta plus 1 sine theta. Theta plus 1 sine theta. Okay, then times the derivative of that. So can we rearrange it and write a sign before I want to use this theta plus 1? Let's arrange that. It's a very cumbersome solution. So that will be sine theta, into bracket theta plus 1, okay, into brackets cos theta, theta sine theta, minus theta cos theta, into bracket theta plus 1, cos theta plus sine theta, all over theta plus 1 squared sine squared theta. So let's expand now. That will be equal to sine theta, leave this one now. Theta times this one, that will be theta cos theta. Theta times this one, minus theta squared sine squared theta. Then the plus 1 times cos theta, that's cos theta. and then minus what? Minus theta sine theta. Okay, finish that and close that one. Then the other one, this one, okay, so that will be theta cos theta, okay, and then times this one, so that will be equal to what? Minus theta square cos square theta. Okay, then theta cos theta times 1, that's cos theta, and then times this one, so that what? That will be also minus theta minus theta cos square theta also, and finally this one also, this is minus times plus, that's minus, and that will be what? Theta sine theta cos theta all over theta plus 1 square sine square theta. Okay, yeah. Yeah, so then the next thing to do now, we can now allow this sine theta code to come in now. So we now have theta sine theta cos theta. Okay, let's check the expansion here. Theta times this, theta cos theta, theta cos theta, theta times this also, that theta square sine theta, so it's not square. Yeah, so that's a mistake there. That will be theta times this will give us this, theta times this, that will be theta square sine theta. Okay, and followed by this one, 1, that's cos theta, and the minus theta cos theta. So that's what we should have there. Okay, this one times this one, we have this one times this one, that's minus theta square sine square theta. Okay, then plus sine theta times cos theta, sine theta cos theta, and then sine theta times this one, so minus theta sine square theta, so minus theta square cos square theta minus theta cos square theta minus theta sine theta cos theta all over theta plus 1 square sine square theta. So this one and this one will cancel out. So those two will cancel out. Those two will cancel out. Okay. Then we can do the arrangements after the cancellation. We can do the arrangements. So we have sine theta. So we have write the positive for sine theta, cos theta, sine theta cos theta. Then here, there's some similarity here. This sine square theta, cos square theta. So we can take the minus theta square out here. So that will be equal to sine square theta plus cos square theta. Okay, this one is gone. This one is also coming together. So take the minus out. So we have plus inside. Okay. Now what again? So I've also written this. That's that. Then the one of theta minus theta. Theta is here. Another one. Theta is also here. So minus theta also into bracket. This will be what? Sine squared theta plus what? If we take minus out, we become plus inside. Plus cos squared theta. So that one's also gone too. So I think we have done all the arrangements all over theta plus 1 square sine square theta. Okay. So final answer will now be equal to sine theta cos theta then minus theta square, because this is 1 and this is also 1, minus theta all over theta plus 1 square sine square theta. Sine square theta. So that's the answer for that question. That's the answer for that question. That's the answer for that question. It's a little bit technical, but the algebra aspect you need to do it gently so that you don't make mistakes. And I believe I want to claim also that it's long a little bit. It's long a little bit. Okay. And what are the things we've done in this question? What we've done is very simple. You just also indicate the numerator and denominator. Differentiate your numerator, which I've done here. Differentiate your denominator, okay, which is also done here. So it now remains substituting and doing the expansion. So if you want to substitute, don't forget this is your v. This one here is your v, and this one here is your du, the theta. Okay. The du the theta, that's your numerator differential, which we have there. Then the other one, so I'm calling it w, so the w the theta. So then followed by what do we have here? Here is what? U the v the theta. Okay, that's your u, that's your numerator, and the differentials of your denominator. We have already done that here. Okay, using that prime on that. Then the only thing we just have to do is just I brought this one in the front. Okay, just to make work easy. It's not compulsory. So you can also try to leave it this way and begin to expand. You get the same answer. So you leave that and then we theta plus 1 time, and then you multiply. We expand this with this, and then we have the bracket here. Okay, and that's what we did. And on the final note, it's just for us to collect together. It's for us to collect together. And I skip something here. This one here, if you multiply this one times this one is theta. Okay, that's good. It's already cancelled out. So cancel out. So just have this one. Okay. Then the next thing to do, begin to observe. This is theta squared, sine square theta. This is theta squared, cos square theta. Factorize the theta squared out. Then you have this. Okay. So that's that on this question. It's very, very, very interesting questions. Okay. So that's that on part 1 on quotient rule. We'll go to part 2 now on the next video. Please join the next video for part 2. And if you are new, please subscribe. Okay. Thank you.